Hi everyone, welcome back. Just want to look at vertical and horizontal lines. Always been something that mucks students up. I pick students up in year 11 and they've seen it for years, but they still don't really understand. If I call a line, let's say I'm going to call it a y line. Let's see what happens when I call it a y line. If I call it y equals 1, where is it? And that's where they go. There it is. So you can see there it is there. What's a brownie? It's a brown line. The interesting part is horizontal. Now, here's the part that makes most common sense to most people. It goes through at 1 on the y-axis. So if it goes to 1 on the y-axis, what do you think it would be called? Y equals 1. So if I had y equals 2, it's horizontal, and it goes through at 2 on the y-axis. And of course, put another one in, let's just jump up a bit. Let's make it y equals 4. And you can see it goes through at 4 on the y-axis. So when it says y equals and there's no x involved, it's just a horizontal line. I do want to go a step further, and I'm going to pick y equals 2 for it. And I'm going to get my table of values up. And I got 5 dots there. I can get a couple more. Let's get 3 and 4. Actually, I'm going to go a lot further. 5 and 6. So if I went across here and I clicked on every point on there, or a bit confusing because the numbers don't quite look in line with the dots. Now that's really interesting. I wonder if I enlarge it, whether it got, that might get better. So if I make it a lot larger, so let's go those 5 there. I'll go that one, a little bit clearer. Now if you look at each of those points, the first number is called the x value and the second number is called the y value. So this one on the left here has got an x value of -1 and a y value of 2. Next point, x value of 0, so I'm laughing about it, and the y value of 2. I hope you like me laughing. I do have fun. Next one, an x value of 1 and a y value of 2. So people say, but why do we call it y equals 2? And you look at this and go, the first one has y equals 2. The second one has y equals 2. The third one has y equals 2. The fourth one has y equals 2. So is there any reason why, any doubt in your mind why it should be y equals 2? So let's make it y equals 3. I hope the table still works. No, it didn't. I had to refresh the table. So let's get the table again, get the table. I only need a few dots. And here we go. I'll get one more. Let's go 3. Wait, I didn't get it. Didn't work. That was strange. I want 3 there. Won't let me get 3. There it is. So if I clicked on those 5 dots, really obvious. They all have a y value. Let's have a look, point to them. See? First one, y value of 3, y value of 3, y value of 3, y value of 3, and y value of 3. Oh, it's repetitive. Now let's get x equals 3 and see what happens. So all I'm going to do on this graph, you can still see the x-axis and y-axis. I'm going to make this x equals 3. Now instead of going through 3 on the y-axis, it goes on 3 on the x-axis. So that enough is enough a reason to say, look, it goes to 3 on the x-axis. It's going to be called x equals 3. So if I clicked on this one here, it's 3, 0. So it's got an x of 3 and the y of 0. If I click anywhere, even that one, an x of 3 and a y value of 0.6. Let's click that one there, x of 3 and y value of, look, and you can just follow it up. Ready? Is the 3 changing? No. So all the way up here, x is 3, but the y value is changing. Oh, that's really good. And if you go down to the negatives where people muck up, so that's 3 negative 0.5. So if I move the screen up, let's get another point here somewhere. We can go right down here. There's 3 minus, oh, nearly up to 3 minus 2. So now here's one last thing because teachers love to ask you this. Let's have a look at it. If we had x equals 3, so that's a vertical one that goes through 3 on the x axis, and the horizontal one that goes through y equals 2 on the y-axis, they cross over each other at this point here. And have a guess what the point is? If I can get it, there it is. So the x is 3 and the y equals 2. So it's 3, 2. Now if you look at the grids, it means you've gone across 3 and up 2. So x equals 3, y equals 2, intersects that, 3, 2. which is nice. If I made it y equals 1, now it's going to intersect at 3. So it's going to x equals 3 and y equals 1, highlighting on the left. So now it goes through at 3, 1. Interesting. I can go worse because it does muck people's brains up. If I go right over here and I say x is minus 3, last bit, so the video doesn't get too long. So I've got x is minus 3. This, I don't know what colour it is. I think it's green, horizontal line. Goes through at 1. So the blue line goes through at minus 3. So you can see this little minus 3 here. So that's minus 3 on the x-axis. So x equals minus 3. I'm going to highlight it up there. Oh, look at that. It comes up clearer. That's that blue line that's vertical there. And y equals 1. If I highlight that, that's that green line across there. And again, where do you think they intersect? If it's called x equals minus 3 and y equals 1, they intersect at minus 3, 1. My goodness, I've seen, no, it's not hundreds, thousands of students just not get that. But thanks for watching, and bye for now.